You ever wondered how a web browser works? What happens when you type in a URL and hit enter? What goes on behind the scenes? To summarize, a web browser is basically a HTTP or a HTTPS client that sends a request to a host and receives a response from the host and uses that response to render a user interface on the browser screen. I will show you how to write a simple HTTP client using Python socket. If you're not familiar with Python programming language, you can still follow this tutorial because the socket interface is available in other languages as well. Let's get started. So what are sockets? Sockets are low-level networking interface. Sockets are used in network programming to enable communication between two devices over a network. They serve as endpoints for sending and receiving data across a network. To start writing our HTTP client, I created a Python file. Let me import socket. I'll make a method here just to make a HTTP GET request. I'll pass in an argument the host. Okay. So inside this, the first step is to create a client socket. So for that, we'll be writing equals to socket. So here we have to specify what is the address family we want to use. So we want to use IPv4 address family. So we have to specify here socket dot AF INET. Now we also have to specify whether we want to use TCP or a UDP form of communication. So we want to use as TCP. So we'll be using TCP over here, and we do it by writing socket.sockstream. So now we have our client socket object. I will add a timeout to the client socket object. Basically, this time, if any operation like connection or receiving data takes longer than this timeout, it will raise a socket.timeout exception. So this is how we do it. Socket.set timeout. Let's say I will set a timeout of like 5 seconds. Okay, so now we need to connect to the host. Okay, let me add some comments here. So to connect to the host, we write client socket dot connect. And inside this, we have to provide a tuple of the host and the port number. So any HTTP service uses port number 80 by default. If you are using HTTPS service, then the port number is 443. Not go into details about the port number, but the port number is basically used to specify the service or application on a host that the client wants to communicate with. A host may have multiple services or applications running inside it. So the port number helps us identify the service we want to communicate with. If we want to create the GET request, so we create a byte string. This is something like this. I'll explain it after writing this. 1.1 send host start encode, then another byte string. Okay, this is our GET request string. So this selected person is a start of the GET request. Basically, it specifies the protocol and the version of HTTP. And we are also specifying the host. Basically, we are encoding it into a byte string, specifically UTF-8 encoding. This last part over here marks the end of the HTTP headers. Now we send the GET request. And we do it by client socket dot send all. So this will send the entire GET request string to the host. After it had sent the GET request, response now. So I'll create an empty response. Initially, it will be byte string, and I'll write a while loop inside here. While true, data equals to client socket dot recv 4096. So basically, we'll be receiving our data in a buffer size of 4096 bytes. 96 byte buffer size is a convention widely used in examples and real-world applications. It is a well-tested size that balances performance and practicality, making it safe choice for many applications. At any point we stopped receiving data from our host, then we can assume the host will not send any more response. So data break response plus equal to data. We need to do another thing here, monitor for timeout. So let's say I'll include it inside a try except block, except dot timeout break. So we had specified earlier a timeout of 5 seconds here. So if our client socket takes more than 5 seconds here to receive any data, then we'll just break from the loop. We have completed receiving the response from our host. Now we can close our client socket object. Now we return the response. So we also have to decode this response because whatever we have received from the host, it's in UTF-8 encoding. So we have to decode it now. And yep, that's all we need. Now I need to execute this method here. So if name equals to main. So let's have some fun. Google.com. Make get request and host. I pass in the host here and I print the response. So what this code will do is send a GET request to google.com and it will receive a response and print the response on our terminal. So now I am in my terminal ready to execute this Python code that will send a GET request to google.com. So I'll run it like any other Python program. Now I hit enter. Oops, something went wrong. So let me just verify my code again. Okay, the problem is I need to add an extra space here. As you can see in line number 12. So I added this extra space here. Now let me save it and rerun my code. As you can see, after running this code, it sent me a bunch of HTML, CSS, and JavaScript code. So this coming from google.com host. So we try to query it with a HTTP request and it sent us this response. What we can do is go ahead and copy this response. I copied it. I'll create a new file and I'll paste it here. And I will save this file as test.html. What I can try to do now is to open this HTML file in a browser. Here you go. So this is the HTML file open in the browser. As you can see, this is similar to the google.com page. And yeah, there are some things lacking here, like the UI is definitely lacking some things here. That's because google.com makes some additional requests with the help of the browser to fetch all the UI components and all the functionalities. But ours make any additional request. We just, so yeah, this is how basically a browser works. It sends a HTTP request or an HTTPS request and receives a response, executes the JavaScript, handles the user events, and displays the UI on the browser screen. This is how basically all the HTTP clients in the world work, with minor modifications here and there. I will probably create another video going into details of the socket and any other networking interfaces. Like this video, hit the like button, and don't forget to subscribe. See you guys next time.